Thank you all for waiting. The workshop will begin shortly. Welcome to the 17th M4DT Day, organized by the Working Group on Metrology for Digital Transformation, STEAM MWG14, of the Inter-American Metrology System, STEAM. My name is Rodolfo Souza, and it's my pleasure to be your moderator for your today's event. Briefly about me, I am an expert in digital transformation in Metro Brazil, and also with Edwin, the coordinators of STEAM Metrology Working Group 14. Before we begin, I'd like to share a few important guidelines. This event is being recorded. I hope that starts to record now. Also, if you would like to ask a question, please use the questions and answers buttons available at the top right of your screen. When submitting your question, please write your name first, followed by your question. Next to the Q&A icon, you will find a subtitles icon that allows you to activate automatic translation in your preferred language. Feel free to enable this and select your desired language. The STEAM Metrology Working Group 14 was created to promote collaboration on digital transformation among national metrology institutes across the Americas. Through initiatives such as M4DT Day series, the working group provides a space to exchange experience, discuss emerging technologies, and strengthen cooperation with regional and international organizations. If you would like to learn more about our activities, tasks, and forces, previous events, and available presentations, we invite you to visit our website. The link will be shared in the chat. Today, we will discuss a topic that is becoming increasingly important for the international metrology community, the BIPM digital framework. Digital transformation is changing the way metrology services are delivered and how trust is established in the digital world. Today's event gives us the opportunity to explore both the international perspective led by BIPM and the regional perspective developed within TIM. I would especially like to welcome and thank you our two distinguished speakers. First, Mr. Cristhian Paredes, Liaison Officer for Digital Transformation at the Bureau International des Points et Mesures, BIPM, who will present the latest developments of the BIPM digital framework. We are also honored to welcome Ms. Claudia Santo from Uruguay, who recently completed her term as Secretary of Inter-American Metrology Systems, SIM. Claudia has played an essential role in strengthening cooperation across Americas and has been a stronger supporter for digital transformation initiatives within TIM, including the creation and development of the SIN Metrology Working Group 14. Today's event is also the opportunity to recognize and thank her for her dedication and outstanding service to our metrology community. We hope you enjoy today's event and take full advantage of the presentations and discussions. Today's first presentation is entitled SI Digital Framework for the SIM. It's my pleasure to introduce Mr. Cristhian Paredes. Cristhian is the Liaison Officer for Digital Transformation at the Bureau International de Poids Mesures, BIPM. He holds a master's degree in chemical sciences and began his professional career as a chemical metrologist at the National Institute of Colombia. He joined the BIPM in late 2025, where he supports the development of new digital services that contributed to the digital anchor of trust for the international metrology community. Please join me in welcoming Mr. Cristhian Paredes. Cristhian, the floor is yours.
Thank you very much, Rodolfo. It's a big pleasure to be here presenting for the SIM region. The SIM is a very important region for me, as I came from the National Metrology Institute of Colombia, and thank you very much for the invitation to be here. So I am here on behalf of the BIPM to share the results of an important aspect of the BIPM work program in digitalization. As you mentioned, the SI digital framework and the core part of it, which is the SI reference point. And this is a result of a teamwork, of a heavy lifting developed by a teamwork of a task group of the Forum ND on the SI digital framework task group. And I hope to represent their efforts accurately. So we always talk about quantitative information in science, and quantity values can be expressed as a number and a reference. This is the first fact from the VIM, from the International Vocabulary of Metrology. And as much as several references can be established, we are not happy with any random reference. We want this reference to be worldwide recognized so we can trust this quantitative information. And this is what modern metrology is all about. So the single most successful system of worldwide recognized references is the International System of Units, of which BIPM is the custodian and the promoter. So this is the mission of the Meter Convention. The Meter Convention is the anchor of trust for quantitative information, for information that can be expressed using metrology, because it is ensuring unification of measurements in the form of the SI. And the SI is specified in the SI brochure, document that I hope you know. It's a PDF document that teaches us humans the definitions of the units of measurement, how to materialize such definition into real-world experiments, and how to use this SI, how to write down the quantity values in a way that it can express unequivocally quantitative information about phenomena or substances or bodies, as the VIM states. Because we are all aware of the issues that might arise if we are not making responsible use of units of measurement. So I have brought this example, this infamous example in which in this was in 2009, a patient was prescribed 0.5 grams per day of a barbituric, of a sedative, and during half week, the hospital staff administered 0.5 grams per day of this medicament, and the health of the patient started to deteriorate. And then they realized that a GR was not a gram, but a grain, which is one order of magnitude smaller than a gram. So what they were delivering during 3 days was reaching the threshold of what the euthanasia dosage for this barbituric was, which is 2 grams, which was close to 1.5 grams. So we are all clear that unclear units can be lethal. And that's one of the reasons why we should all stick to the major convention, because if we stick to the SI brochure rules on how to express quantity values, we can avoid such problems, and we can make sure that the prescribed dose is the same as the one that is being administered, which is really important when we talk about human health or about environment protection. But we can argue that those are problems from the past, that this is still an issue if we are using handwriting, which can be like ambiguous, and that such problems are virtually eliminated if we use digitalist data, where computers handle the information. But then we have yet more examples of how this is not completely solved yet. So this is another example from space exploration missions. There was this Mars rover that was supposed to get to the next planet, to Mars, to explore the climate. But this rover crashed against the Martian surface instead of staying in orbit, which was a big accident. And the reason of this was that one team was using the SI units and the other team was using imperial units, and it's when they exchanged their data for their calculations as raw numbers with no units, assuming that the other team was using the same units, this became a big issue, and this was highlighted in this paper that I have in the bottom right corner of the screen, which included a big call for action for the scientific and quality community, making units of measurement machine readable, because this was hindering science. It was converting science not as effective as it should be, just because of the mishandling of units in digitalized information. So we are making the same mistake of this space exploration mission when we store data like this, when we store information as unitless number with without units, where we assume the units can be inferred from the context, that we know that the temperature will be in Celsius degrees, but if we are in another part of the world, that will not be the case. That the pressure will be in hectopascals, but if there is another laboratory that is using millibars, then this spreadsheet will have no use for them, which is an issue. So this digital data stored in this way can be useful, can be good, if we are using this data ourselves in the short term. But this is not what we are intending to do. We want this to be like a long-term stable, and we want it to be useful for anyone that has access, authorized access to it. And if we store the data like this, then we are relying on community practices or common sense, which is not good. And the issue only gets bigger when we don't have only a small data set on a spreadsheet, but we have lots of data coming from sensors that are using raw numbers with no units, like this example that we have here, like humidity as a 62 without including the percentage symbol, for example. And of course, the issue only grows bigger and bigger when we consider sensor networks, when we have several nodes that are sending data to clusters that finally will send the data back to a base station. If all this data is handled without units, then we will have, at the end of the day, a lot of numbers with no context. And we humans can understand context and we can make use of the common sense sometimes, but machines cannot, and it can get troublesome. So we don't want this. We want to avoid this from happening because we want our efforts to be as efficient as possible. And as much as we don't allow written absolute quantities values to be unitless raw numbers that the one that we have here in red, we want units always with the numbers. We should not allow the same situation to happen in digitalized information. We need to have uh, units, clear units in the digital world, and these clear units should have certain requirements. They should have explicit meaning, which will enable consistent interpretation, and they should have permanent traceability. So in the future, we will be able to resolve what we were meaning by any given reference. And this is partially solved by the digital representation of units of measurement, which has the acronym of DRUM. There is an important working group in CODATA from the International Science Council that it's collecting of the digital representation of units of measurement, all the digital system for representing units of measurement that can be and have been for a while used to include this context in the numbers that are handled by the machines. But still, there are certain areas that need to be fulfilled because this digital system for representation of units of measurements lack an authoritative status. They don't have, most of them, linkage to definitions, and they lack worldwide acceptance, which is an important requirement for the references that we want to use to express quantity values. And this is where the BIPM enters. This is what has been tried to solve by the SI reference point, which is the core service of the SI digital framework in the digital services from the BIPM to the metrological community. So the SI reference point intends to extend the role of the meter convention into the digital era. So we want to provide an anchor of trust for metrology, for digital metrology, which is more and more important nowadays that all the organizations are undergoing digital transformation of their processes. And this is a response of one of the resolutions from the General Conference of Weights and Measures that ask this strike to the BIPM to extend the role of the meter convention into the digital era. So what it means is that we need to provide an anchor of trust for the digital information, for the digital measurement information. So the SI reference point features persistent identifiers for the units of the SI, for the prefixes, for the defining constants, and for the decisions of the governing bodies in the method convention. Those are the CIPM and the CGPM. All the decisions that at one given point decided that unit will be defined by a defining constant, and the defining constant will have an agreed upon numeric value, and that the realization of those units will have certain experiments that are accepted to bring those abstract definitions into the real world. And these persistent identifiers, we will see how they are useful and why they are good for. But the SI reference point does not only features persistent identifiers, it also includes a knowledge module, which are ontologies, where we can find all the concepts in the international system of units, all the hierarchies, all the relationships between those concepts, and also how to use those units or those prefixes, those definitions, those defining constants, how to combine units, with prefixes as well, and how to assign them to quantity types. So let's start with the first part, with the persistent identifiers. So in the traditional SI brochure, we have this PDF document that says what are the authoritative definitions of the units of measurements. And in the SI reference point, we have the authoritative digital representation of the same units of measurement. So let's take, for example, the Kelvin. If we take the Kelvin in the SI, it is defined clearly. It is defined which symbol it is used for it, which is the English name and the French name, which are the official languages of the BIPM. And in the SI reference point, we provide a persistent identifier for the unit Kelvin, which has the form of this URL, this unique resource locator that it's like a web page address that unequivocally identifies the Kelvin in the SI reference point as the authoritative reference in the digital world. But it does not only covers units, it covers, for example, the defining constants. So in the SI brochure, in the annex, in the appendix of the SI brochure, we have the relation that the Kelvin is defined in terms of the Boltzmann constant. So we need to have a concept, a PID, for the Boltzmann constant, which also will have the same nature of an URL that we can use, that you can see there in the bottom right corner of the slide. So these PIDs can be used in several ways. The PID of the unit Kelvin that we have here can be included in the databases. It can be included in the digital calibration certificates. It can be used in data analysis workflows. It can be referenced in quality management documents. But the most important use to it is that it will link other drums to the authoritative definition. It can be used as an interoperability layer to make other drums or their digital systems for the representation of measurement units to be interoperable in between them, because it does not intend to replace all the systems that are already established in their communities. It intends to anchor them, to provide them with a ground, with a common ground that they can use for referencing, which is extremely important, because if they have the same reference, then we can all have like a common understanding of what we are talking about. And those PIDs, since they have the way of URL, they can resolve to web pages. So we can, as humans, visit those URLs. It will get us into web pages that have this form that you can see here, which has the definition of the unit as stated in the SI brochure. It will include the basic information about the symbol, which is the defining constant, which is the defining resolution in which that defining constant was adopted. And it will also have the unit type, because you know that there are SI-based units, and there are also special units in the SI that have their special names. But this is human readability, which is good if we want to see what those URLs link to. But for machines, they need to be able to read that information. And this is machine readability of the SI reference point. So this information can be obtained using an API, an application programming interface, and the data can be retrieved in several formats like XML, for example, and this is here you can see what is the beginning of the data that is shipped to a machine that is accessing this URL and that is requesting the content using XML, but it can also be in JSON. Still, this does not enable machine actionability of this information. So for machines to be able to use this information, we as humans need to tell them which is the label of the piece of data that we need to retrieve. For example, if we want the symbol, then we need to tell them like the symbol is under this symbol tag, for example. As obvious as it might seem to us humans, it is not obvious to computers because computers do not have common sense. Machine readability does not automatically enable machine actionability. That's a different layer. And yeah, we cannot rely on computers' common sense. And here we have this very nice cartoon in which it's, of course, it's in imaginary scenario in which a person is teaching a robot to paint, and the machine will repeat a mistake several times perfectly. So we know that machines don't have common sense. They can repeat a task many times per second, but if we instruct the task incorrectly, then they will do it incorrectly millions of times. We cannot rely on that. So we are faced with the big challenge of providing reference authoritative information in a digital world where now with this AI hype, data cannot be plain data without meaning. Because if we have plain data that like this table that we are seeing here, or I don't know, a traditional database or a spreadsheet, a computer will not understand the relationship in between these columns like this. It will see like the units, like the mole, for example. It's defined by the Avogadro constant, but it will only see one number and one string. Yeah, if they are lacking the explicit definition of the relationship, they cannot use this information. So this is bad because machines lack the constant of what are units of measurement, how they can be used, what is a defining constant, and how those relationships or values were defined as the official ones, and which is the governing body that decides what is the official one. So an alternative we could have is to enrich this data to add more columns, but this only solves the issue partially, as the complex SML that we saw before or the JSON, it still does not enable full machine actionability because it does not imply the meaning of this data. What we need is to have linked data. This is a very elegant solution that was developed by important consortium across the world, and that was adopted by the task group of the SI digital framework of the forum MD. So instead of storing the mole as a string and the Avogadro constant as a number, we consider them as resources that have globally unique persistent identifiers that we discussed before, the PIDs, and we establish links between them by using formally defined machine-readable relationships that are also assigned PIDs. So we have the mole that is defined as an Avogadro number, and the three of them, the mole is defined by, and the Avogadro number, they will have their PIDs. And this statement, which has a subject, an action, which is a predicate, and an object, it's known as a triple. And we can link as many triples as we want. For example, this Avogadro number can be linked to the General Conference official resolution that adopted this Avogadro number, and all of them will have persistent identifiers, and all of them can be further aggregated to link more and more data, so we can encode all the knowledge of the SI brochure into a way that machines can understand. And if we group several triples, then we will end up with a graph like the one that you are seeing here, that this graph will express an ontology, and this ontology will have a formal specification of all the classes, all the hierarchies in between those classes, all the members of these classes, and all the relationships in between the members of those classes, stated in a way that computers can reason over. So we have all the units, all the SI-based units, all the specially named units, and all the units that are outside from the SI, but they can be equivalently made to numeric values of the units of the SI, in a way that computers can reason over. And to reason over, it means that they can make inferences and interpret things that are not explicitly stated in the knowledge model that was defined by the task group. So machine actionability of the SI brochure comes in the way of semantic representation, which is known as the knowledge model of the SI brochure, which was baptized as the SI reference point. So this is the SI reference point, and meaning that it is machine actionable, has several benefits, like the benefit that it can be used to define coherent unit expressions that are not manually written, but that are programmatically derived. Like, for example, if you want to express a quantity value for a specific heat capacity that has the units of joule per kilogram per Kelvin, then the system of the SI reference point can be used to generate a PID for this unit expression. And this PID can be resolved to a web page, as we saw before. It can be retrieved as XML or JSON format to access the components of each of these members of this unit expression. And also we can retrieve the machine actionable definition that will have all the data linked in a way that it can be resolved to their components. So we will have what is a joule, what is a kilogram, what does this exponent -1 means, what does this -1 exponent means to the Kelvin, and it can be used by computers in a consistent way. So all of this, it's undergoing like a full publication in a scientific paper that was submitted to Metrology journal. It will hopefully come out soon in the future. This was done by these members that are part of the Forum MD task group on SI digital framework. And the big news is that around 1 month ago, we finally released the first version of the SI reference point. So you can already start using the PIDs, you can interact with the knowledge model, and there will be a launching webinar that I would like to invite you all to attend. It will be later this month on 20th of July at 10:30 UTC. I know it's not the most convenient time frame for the impression. My sincere apologies about that. Yeah, it will be really early in the morning. But if you can, please attend. So there we will have two important talks about how the SI reference point was designed and how can we use this SI reference point in our data management frameworks. But in the meantime, you can already access the web pages of the SI reference point. You have the link here in the bottom of, you will also have access to this presentation, so you can just simply click there. And there you will have like independent units, independent pages for each of the units that are coherent with the SI brochure. And you can also access a unit expression parser where you can derive the PIDs for specific combinations of units that are coherent with the rules that are established by the SI brochure. For example, that you cannot use two prefixes for the same unit, that you need to clearly indicate which unit is being affected by which prefix. All of this, it's already encoded in this web service that you can already use. And then you can have like PIDs for your compound units that you can incorporate into your DCCs, that you can incorporate into your databases, that you can incorporate into your laboratory information management systems. But this is still for us to use, for humans to use. For machines, the BIPM has developed application programming interfaces. So your pieces of software can query our knowledge model, and you can explore how to program your computers to access this knowledge model by reading the documentation web page of the API, which is known as the Swagger page. That is currently accessible from the SI Digital Framework website. So it's an invitation to go there and to visit, to see how is the response body that you will get to certain queries, to share this with your IT teams. And all of this has been released in the repository of the BIPM, which is in GitHub. So if you go to github.com/the BIPM, you can see what is the Python code that generated the knowledge module of the SI brochure. You can also access the Turtle files that underpin the ontology of the SI brochure. And you can also hopefully submit some feedback. You can post your questions and your comments in an open way in this URL that you have here in the issues webpage of the repository of the SI Digital Framework in the GitHub of the BIPM. So I hope to see you all in the launching webinar that will happen in 20th of July. I hope to see some of your comments in the issues webpage of the repository. And more than that, I hope that you will all benefit from using this tool that will provide an anchor of trust of metrology for the digital era. And that will be all on my side. Thank you.
Thank you, Cristhian, for your excellent presentation.
Thank you.
We will now open the floor for the questions. I have some questions, but I will let the people here submit their questions. There is a button Q&A to put your questions. If there is not any question up to now, I can start.
There is a question, sorry,
okay,
from
yes.
Alexander Gutierrez Guevara, but it was posted as a comment. That's probably why it is not that visible. So he says, thank you, Alexander, for the congratulations. This is a great advance towards consistent DCCs or another applications. The question is, what does the D stands for in PID? PID is a persistent identifier. Yeah, it's it could be only PI, but ID is assumed as the acronym for identifier, so it's only persistent identifier. Yeah, the D, it's only one middle letter of identifier. I don't know, yeah, why it was included. It's not digital identifier, it's only identifier. Yeah. But
Yes.
yeah, please go ahead.
Any more questions? I have one question, more than one. The SI reference point is not for the use of only the metrology community, but it could be used by almost all the scientific engineering and communities. Do you have some records of who is using the SI reference point and the page views, something like that?
Yes, this issue of computers not being able to handle measurement units, it's not new. It has been already worked on for a long time, and that's why CoData has this drum task group that it's collecting all the community standards for representing units of measurement in digital information. So we have, for example, QIDT, we have, which is already used by a number of applications. And this QIDT is linked to the SI brochure, to the SI reference point. There is an important work that was developed by PTB with the IAC, with the International Electrotechnical Commission. They have also their common data dictionary that has their own digital representation of units, and this common data dictionary has also been linked to the SI reference point. So all these applications that are using QIDT or that are using the common data dictionary from the IAC, they are equivalently and interoperably compatible with the SI reference point, which means they are sharing now a common grounding, and it is improving the interoperability of this data. We hope that in the future, all the drums will be linked to the SI reference point, so they can be converted in between them in a consistent way that will prevent them from inducing like modifications of the intended values. So we can trust them as much as we trust quantity values that are expressed analogically using the SI units.
Thank you. Any other questions? I have a list here, but from the audience, is there any other questions? No, I have another one. I know that the SI reference point and the digital framework is in English and French.
Yes.
And for computers, English and French is more than sufficient enough. But do you think it's a good point to some national institutes organize official translations of the SI reference point, or seen, for instance, an official Spanish translation of the SI reference point, at least to help the people who are going to develop systems in the using these things?
Yeah, I think that will be useful. Currently, the official languages of the BIPM are French and English. So the as a reference point in the official repository of the BIPM, so far it will only include French and English. But I think it will be useful to have more languages. The good thing is that these ontologies will allow language tags to be added to the data. So a single resource can have several languages attached to it. And as long as the repository has been made public, now you can reuse the Python package that generates the SI reference point, and you can propose your patches that will have the the official translations. But yeah, it's a difficult question because I don't know which institute will get to do the official translation to a certain language. But of course, we can accompany the development of the ontologies with the different languages. But yeah, all those efforts are more than welcome.
Okay, thank you. There is a question of Javier Arias from Panama. Cristhian, since you are at the BIPM now, how would you compare the use of digital SI among all the RMOs? Are all RMO using it?
Thank you, Rodolfo. Thank you, Javier, for the question. It's a good question. So far, one of the challenges, one of the constraints that many institutes have expressed regarding the use of the SI reference point was that it was in a beta stage, that it was not officially released. This just happened a couple of weeks ago, that the SI reference point was released officially as the first stable version. We ran a questionnaire late 2025 asking people how they were asking the NMIs and designated institutes how they were engaging with the digital services from the BIPM. Some RMOs were good represented in the survey. So far, the biggest users of the SI reference point are in Euromed, followed by SIM, but these conclusions might be based on an incomplete image of the people that answer this. So we will be working this year and next year in promoting these tools, in making the metrologies more confident and more familiarized with this tool on how to use that. So everyone will be on board, hopefully, and everyone will be proposing tools that are interoperable across all RMOs. So SIM is doing good, of course. It's a big RMO that it's at least the top 2 RMO using the digital the SI reference point. But yeah, we still need to work a lot more in having everyone on board.
Okay, we have a last question. We are 5 minutes late. From John Nishan-Nambu, sorry if I not spell right your name. Do you know any efforts to also make imperial units digitally available?
This is a nice question. The SI brochure is not static, and the same way that the SI brochure is not static, the SI reference point it's not static. And the SI brochure is currently in the 9th edition, version 4.0, 4.0. And in this last version of the 9th edition of the SI brochure, the big change that was included was that in the past, there was a distinction in between non-SI units that were accepted for use inside the SI and non-SI units that are not accepted by the SI. Now they are all simply non-SI units. And the new version of the SI brochure has a table, a new section, which includes a table of non-SI units. And it clearly specifies that this is non-extensive description of those units. So it has, for example, the nautic mile, which was not in the past in the SI brochure. Now it appears in the SI brochure. So in the future, in the some future, it will appear in the SI reference point. But the good thing is that now we have more liberty to include all the units that are important to our community that are not explicitly defined in the SI brochure, but that will have room in the SI reference point. So that's exactly what the GitHub repository is for. So if there are units that are important to the community and you will like to have them in the knowledge model of the SI brochure, you can file us an issue that is a formal petition for inclusion of these imperial units into the knowledge model of the SI reference point. So this is something that we are still working to solve. But yeah, you can make the official request, and then we will discuss the inclusion of such units in the knowledge model of the SI brochure. Thank you, Jean.
Thank you once again, Cristhian, to stay with us, share all your knowledge, and for answer the audience questions. We have late time, so we can go on. And I also recommend to the people to see the GitHub from the BIPM. I think it's a very important place to participate and comment mainly the issue link on the GitHub to discuss what your doubts and what you get on with the SI reference point.
Yes, thank you.
Thank you. Now our second presentation is entitled Cooperation, the only way to build a better future for everyone. It's my great pleasure to introduce Ms. Claudia Santos. Claudia Santos is a chemical engineer from Uruguay and currently works as an independent consultant in the metrology and management. She served as a secretary of the Inter-American Metrology System, SIM, from July 2018 to June 2026. Throughout her career, she has made significant contributions to scientific metrology, accreditation, quality infrastructure, and international cooperation. She served as Director of Scientific Metrology at LATO, chaired the SIN Technical Committee, represents SIN at the GCRB, participated in numerous international cooperation projects, and has contributed to the development of the metrology across Americas for more than 25 years. Many of us have privilege of working with Claudia over the years. Her leadership, commitment, and collaborative spirit have been fundamental to strengthen SIN and support initiatives such as the Working Group of Metrology for Digital Transformation. Please join me in giving a warm welcome to Ms. Claudia Santos. Claudia, the floor is yours.
Muchas gracias, Rodolfo, por esta amable introducción. Es un placer estar aquí y haber sido invitada por el grupo de trabajo 14 en transformación digital. Aquí compartimos el Metrology for Digital Transformation Day el 17º día, los dos extremos de las carreras, ¿no? Está Cristhian recién, bueno, ya con su carrera también un poco avanzada ya en el BIPM, y yo aquí terminando en el SIM. Por supuesto que agradezco entonces la invitación y decirles que igual estoy dentro de la metrología porque afuera del SIM igual sigo siendo un apóstol de la metrología y de la infraestructura de la calidad. Bueno, esto va a ser una presentación que quizás no sea habitual en estos Metrology for Digital Transformation Days. Ok. Bueno, les voy a hablar un poco del SIM, de mi experiencia en el SIM en estos bastantes más de 25 años que decía Rodolfo. No dentro del SIM, pero sí en la metrología, ¿no? Y lo que fui aprendiendo a lo largo de mi participación en todo este mundo, que en un principio fue nuevo para mí, pero luego fue creciendo hasta, como les decía, lograr un sentimiento de ser apóstol de la metrología y de la infraestructura de la calidad, ¿no? Bueno, la primera pregunta que quiero traer a reflexión es ¿por qué organizaciones como el SIM se necesitan para fortalecer la cooperación a nivel regional e internacional, ¿no? La cooperación no es algo que se dé naturalmente, sí se da naturalmente en el diario vivir, pero que hay que trabajar mucho para lograrla. Y sobre todo para lograrla en organizaciones y en organizaciones regionales e internacionales, ¿no? ¿Cuáles son las ventajas del SIM o de organizaciones como el SIM para promover y fortalecer la cooperación entre los países? Y acá estamos hablando fundamentalmente de cooperación técnica, porque el SIM hablamos de cooperación en metrología, pero también va mucho más allá de la cooperación técnica, ¿no? Porque se dan la cooperación adentro de las organizaciones y de unas organizaciones con otras, y esas cooperaciones entre organizaciones traen un amplio espectro de acción, ¿no? De ese ámbito de cooperación, ¿no? Las ventajas que tiene el SIM en el tema de cooperación es que históricamente ha sentado a todos los miembros en una misma mesa y a un mismo nivel. O sea, no hay un miembro que tenga mayor valor que otro. Todos los miembros tienen el mismo valor, su palabra tiene la misma atención, y así, con todos estos miembros participando de una misma forma, se logran soluciones a los problemas de todos, desde los más grandes hasta los más chicos, y soluciones en una forma inclusiva, o sea, que no dejan a nadie de lado, que compartan el mismo problema. El hecho de contar con personas de diferentes lugares, con experiencias, con necesidades diferentes, con formas de pensar diferentes, lejos, pero muy lejos de construir una desventaja. Constituye una oportunidad, siempre constituyó una oportunidad para el CIM. Nunca hubo miedo a la confrontación de ideas, a la discusión para encontrar una mejor solución, para lograr mejores soluciones para todos, para concientizarnos de que escuchando al otro nos vamos a dar cuenta de que existen realidades alternas a la nuestra y quizás eso conduzca a soluciones alternas a la nuestra, que sean más inclusivas y más efectivas a nivel global. Muchas veces, si no se dan estos tipos de discusiones y para darse este tipo de discusiones es importante la confianza, el saber que el otro me está escuchando con respeto, el saber que el otro me está entendiendo lo que digo y me está queriendo ayudar, está queriendo cooperar conmigo y yo con él. Esto creo que es un gran valor del CIM, el contar con representatividad, con credibilidad y con reconocimiento. Esto facilita el acercamiento entre nosotros, entre los miembros del CIM, pero también la aproximación a organizaciones pares y a la creación de sinergias con otras organizaciones pares que trabajan en mismos temas, infraestructura de calidad, metrología, otras temáticas como competitividad, sostenibilidad, etcétera, ¿no? Pero una de las cosas que quiero recordarles y que he aprendido en todos estos años es que es fundamental tener en cuenta que todo esto, sea la representatividad, la credibilidad y el reconocimiento, no son cosas que se crean en un solo nivel. Esto se crea a todo nivel en el CIM, desde los grupos de trabajo, desde el QSTF, desde el consejo directivo, desde los miembros, desde cada uno de los metrólogos que trabajan en cada uno de los institutos de metrología del CIM. Y se crea todos los días. O sea, nosotros podemos crear confianza durante años que si un día hacemos algo que quiebra esa confianza es muy difícil de recuperar. Entonces, esto es un trabajo diario y de todos, el crear esta confianza que nos permita lograr los objetivos que venimos logrando dentro del CIM. Lo importante es que nosotros estamos queriendo lograr un éxito, ser una organización exitosa, eso lo dice nuestra visión, pero el éxito como organización depende de que todos los miembros y todos los stakeholders ganen junto con nosotros. O sea, la ganancia de ningún miembro puede ser a costa de la pérdida de otro. Y esto requiere una gran apertura mental, requiere ponerse en el lugar del otro, a través de discusiones, de negociaciones abiertas, de negociaciones productivas. Y eso es lo que se ha encontrado o yo he encontrado en el CIM a lo largo de todos estos años. Y bueno, es un lugar donde se han llevado a cabo los principios corporativos principales de las organizaciones, participación voluntaria, democrática, aportes económicos, autonomía, independencia, educación, entrenamiento, información, comunicación, diría yo, cooperación, entre todos los miembros y preocupación por la comunidad. Y acá creo que es uno de los puntos más importantes. Bueno, ahora les voy a contar un poco de mí, de mi historia, de por qué elegí hacer una carrera en el SIM. Lo primero que nos enamora de una organización son los objetivos que tiene, ¿no? Los valores que tiene. Y no solo los que están escritos. O sea, nosotros vamos a ir a la página web del CIM y vamos a ver la misión, la visión, los objetivos, los valores, etc. Pero eso nos puede movilizar un poco las neuronas, ver si se alinea o no con nuestros propios valores, pero lo que realmente convence en una organización son los valores que vemos vividos por la gente que la integra en el día a día. Yo, a medida que me fui acercando al CIM y a nuestra comunidad, fui encontrando gente muy valiosa, que tenía estos objetivos y estos valores muy claros y que se comprometía con ellos y que los vivía con entusiasmo. Y todo eso en mi interior fue lo que me movilizó a ser parte de esta organización. Valores como confianza, responsabilidad, objetivo, ética, trabajo en equipo, etcétera, metas. La cooperación la fui viviendo en distintos niveles, ¿no? En el primer nivel que estuve involucrada, quizás como muchos de los que están presentes acá en la charla, fue a nivel técnico. Yo trabajaba en el LATU, tenía el cargo de responsable de masa y magnitudes relacionadas. Y en ese rol empecé a trabajar en el grupo de trabajo de masa y magnitudes relacionadas. Después el LATU empezó a trabajar en metrología química y me nombraron a su vez responsable de esa área. Y empecé también a trabajar en este otro grupo de trabajo. En estos grupos de trabajo, como el de transformación digital, es donde está el cimiento técnico del SIM. Y eso fue un poco lo que yo fui descubriendo. O sea, acá nos encontramos en los grupos de trabajo los técnicos que conocemos de determinadas magnitudes y que estamos en distintos niveles de desarrollo con distintas necesidades, pero que logramos en nuestros compañeros de grupo, en otros metrólogos de otros institutos nacionales de metrología, el apoyo para crecer. Y para crecer en las metas que tiene cada uno, ¿no? Porque cada instituto de metrología tiene diferentes metas. Obviamente estamos en diferentes economías, en diferentes países, con distintas necesidades y por lo tanto las necesidades metrológicas van a ser diferentes. Y lo importante es tener en claro eso y llevar adelante esa cooperación en lo que cada uno necesite. Para eso es importante la labor constante y el compromiso de cada uno de los miembros de los grupos de trabajo, desde el primero hasta el último. O sea, acá se van a necesitar investigaciones, se van a necesitar comparaciones, se van a necesitar desarrollos y todos tenemos que estar involucrados y llevando esa metrología que nuestra región y el mundo necesita para que las mediciones sean confiables y para desarrollar otras áreas de conocimiento. Bueno, luego de participar en estos grupos de trabajo, me voy dando cuenta que el trabajo interno en la región es importante, pero que el mundo es mucho más grande y que es necesario abrir la cabeza al mundo y ver más allá de lo que estamos viendo en nuestra región, ¿no? Por esa razón decido postularme como presidenta del comité técnico y representante ante el JCRB, y ahí tengo una gran oportunidad de asistir a las reuniones del JCRB, de participar con otras organizaciones regionales de metrología de las reuniones, y de que ese nivel de cooperación y discusión se vea enriquecido y ampliado. A su vez, me da la oportunidad de interaccionar con las otras ramas de la infraestructura de la calidad, la acreditación, la normalización y otras áreas de conocimiento, como les decía, en las que influye la metrología, la globalización, la competitividad, pero sin olvidar toda la parte de humana que hay atrás y la parte de sostenibilidad, ¿no? Y bueno, y todo esto nos va enriqueciendo y nos va viendo, porque una cosa es ver la metrología desde adentro y para qué me sirve, y otra cosa es ver la metrología para qué sirve a otras áreas de conocimiento, para qué le sirve al mundo, para qué le sirve a la humanidad, ¿no? Y entonces, en ese momento también, como parte de como presidenta del comité técnico, paso a formar parte del consejo directivo del CIM. Y acá es otra beta que también quería compartir un poco con ustedes. Acá voy cayendo en la cuenta de que todo este conocimiento, todo esto que yo había recibido del CIM y que a su vez también había dado, conllevaba una responsabilidad, ¿no? Participar en la conducción del CIM, el proponer, el construir, el acordar, planificar, el construir el futuro del CIM. Y bueno, y fue una tarea que traté de asumir con la mayor responsabilidad que pude. Fue allí que empezamos en el consejo directivo a pensar en una mayor formalización del CIM, el cambio de estatutos, la conformación de una entidad legal, entre otros planes. En el tema de la entidad legal, como la entidad legal se constituyó en Uruguay, me tocó apoyarla directamente en mi rol de directora de Metrología Científica del LATU de Uruguay. Y bueno, y luego de todo esto, di el último paso. En julio de 2018, el Consejo Directivo del CIM me ofrece la posición de secretaria ejecutiva, y lo consideré como un desafío que acepté honrada, con el propósito de seguir construyendo desde este nuevo lugar. Y bueno, por último, en todo este camino que aprendí, ¿no? Porque si uno camina y no aprende, no camina. Se tropieza, se levanta y sigue caminando y sigue aprendiendo. Entonces, compartirles un poco de lo aprendido a lo largo del camino. Bueno, he aprendido que las necesidades de todo el mundo, de todos los institutos, de todos los miembros, de todos los países, no son las mismas. Cada miembro del CIN tiene sus propios objetivos y el resto de los miembros tiene que conocer no solo sus objetivos, sino los objetivos de los demás, porque es la única forma en que vamos a poder cooperar con los demás para ayudarlos a alcanzar o apoyarlos en alcanzar sus objetivos. Pero cuando un miembro alcanza sus objetivos, todo el CIM crece y todo el CIM gana. O sea, que esto de cooperación es un ganar-ganar. O sea, construimos juntos, apoyamos al otro, ganamos yo recuerdo que cuando era directora de metrología del LATU es uno de los institutos metrológicos más pequeños, uno de los países más pequeños de América, y cuando yo entré trabajando como metróloga, ¿no? Teníamos proyectos de cooperación, fundamentalmente recibíamos cooperación desde afuera. Y cuando yo fui creciendo en mi carrera y llegué a ser directora de metrología, ahí me empecé a replantear. La cooperación hay que recibir y dar, porque esto va en dos vías. O sea, no tenemos que esperar todo que venga de afuera, tenemos que apoyarnos, porque si no nos apoyamos, no crecemos. Y el LATU, Uruguay, tiene algo que dar al CIM. Y si no tenemos que dar, podemos contar lo que nos hemos tropezado y cómo hemos avanzado. Y así fue que también empecé a promover la cooperación desde los institutos pequeños hacia afuera. En el CIM, eso es un valor súper importante. O sea, no son solo los institutos grandes los que cooperan, sino que desde el más pequeño hasta el más grande, si uno ve quiénes ofrecen de pilotos de comparaciones, quiénes son miembros del consejo directivo, tenemos institutos pequeños, institutos grandes, institutos gigantes, todos dispuestos a cooperar, ¿no? Lo otro importante aprendido es que juntos lo hacemos mejor. Todas las opiniones cuentan. No importa hacer las cosas rápido, es más importante hacerlas juntos. Los líderes en los grupos son importantes, pero no son más que un miembro más del grupo. Y las cosas importantes que se alcanzan cuando se alcanza una meta es más importante la meta que quién la logra. Entonces, no dudemos nunca en ceder protagonismo. Es algo que siempre tuve claro en mi vida. Digo, es más importante la meta que el protagonismo. Y la frase esta, ¿no? Juntos todos llegamos más lejos, llegamos a más. Y por último, el último aprendizaje que les quiero dejar es que las personas son el centro. O sea, podemos tener organizaciones, podemos tener tecnologías, y acá en el mundo de la transformación digital estamos con tecnologías de avanzadas, pero esas tecnologías se tienen que usar en un marco donde la persona sea el centro, donde la equidad se mantenga, donde los valores éticos y los valores organizacionales sean utilizados y nunca sean olvidados. Que lo primero que tenemos que apoyar para que crezcan las organizaciones es a la gente. Y que si esto no se lleva a cabo, ni las organizaciones ni las tecnologías van a apoyar, a crear un mejor futuro en el cual estemos todos incluidos. Bueno, esta es mi última reflexión y se las dejo para pensar y quedo ahí mis contactos y a las órdenes.
Thank you once again, Claudia, for sharing your experience and for us. Thank you very much, Claudia, for your inspiring presentation. Okay, first we will open to Javier Arias, former president of CIN. He wants to address some words to hear. Javier, would you?
Yes, can you hear me? Yes, Rodolfo. I hope you can all hear me. Javier Arias, former CIN president, actual vice president, and one of the members who has worked with Claudia for I don't know how many years already. As Claudia said, she recently left CIN and ready to enjoy the independent life after so many years working for us, not just for CIN, for as she said, for the whole community, for the whole meteorological community. And one of the messages that I would like to give all of you in the name of Claudia also is what she just said at the beginning. At the beginning, we had here Cristhian, who is a young meteorologist, a really world value in CIN, young meteorologist, starting his career. And through Claudia's conversation, we were able to hear how her career was building year after year to a precious moment now in which she decided to actually leave, but pass the baton to new members. And that's what I guess she's doing at this moment, telling us how we have to first love what we do and work together as a community, work together with international relationship to actually build up this community. So Claudia, thanks a lot for everything you have done for CIN and for the worldwide meteorological community. You know we are gonna miss you a lot. You know you keep being part of this community. For all of you that do not know, Claudia just left 9 days ago. It was her final day, so she's now an independent person. And we also would like to take this opportunity to thank you in the name of 133 persons being here present, because when you left 9 days ago, it was only the same council that was able to actually know that you were there, know that you were leaving. So I'd like to take this opportunity in the name of the whole CIN community and the meteorological worldwide community to thank you in person for all the great job that you have done through all these years. Thank you a lot, Claudia. Thanks a lot, really, in my name and in the whole CIN community. Thank you.
Gracias, Javier, por tus amables palabras y gracias a toda la comunidad, porque esto no se construye solo, ¿no? Como decía recién, lo construimos entre todos. Y gracias a cada uno de ustedes, porque de cada uno de ustedes yo me llevo algo y estoy seguro que nos vamos a estar cruzando en el camino de la vida y que vamos a seguir compartiendo, y acá estoy para cuando me necesiten. O sea, me escriben y lo que necesiten, a las órdenes.
Okay, Claudia, thank you again for sharing your experience and for, I think it's not necessary to answer questions. I think CIN will feel a lot of your departure. Sonia is arriving, but your time in CIN was very, very important to us. And so we are late in time, and as we are come to the end of today's event, I would like to express our sincere appreciation to both our distinguished speakers. First, I would like to thank Mr. Cristhian Paredes, a new meteorologist, a young meteorologist from BIPM, for present the last development of BIPM digital framework, and for sharing how international digital initiatives are helping to build a trusted digital infrastructure for the global metrology community. Your presentation has provided valuable insights into the future of digital metrology and opportunities for regional collaboration. I would also like to express our deepest gratitude to Ms. Claudia Santos. Claudia, thank you for your remarkable dedication and leadership during your years as Secretary of SIM. Your commitment has helped to strengthen cooperation among national metrology institutes throughout Americas and has contributed to the development of many, many important regional initiatives. The Working Group on Metrology for Digital Transformation was created during your time as Secretary, and from the very beginning you supported this vision. And from the very beginning, and encourage its activities and believe in the importance of digital transformation for our region. For that, we are sincerely grateful. On behalf of the entire SIM Metrology Working Group community, thank you for your friendship, your leadership, and your continued support. We wish you every success in the new stage of professional journey, and we hope to continue working together in the future. Finally, I would like to thank all participants for joining us today. We look forward to seeing you at the next M4DT Day. Have a wonderful day, and thank you very much. Thank you all. Thank you, Claudia.
Thank you, Claudia. Thank you very much for all your effort.
Thank you. Well, see you anytime.
See you.
See you.
Congratulations, Claudia. I wish you have a happy retirement now.
Thank you so much, Cristhian. It was a pleasure to share with you so good moments.
Thank you. It was really nice to meet you in the past. Bye.